G'day students, today we are going to do the opposite of expanding using the distributive law. We're going to factorize using the distributive law. So we want to put stuff back into brackets. So we're going to work backwards from yesterday or last lesson. So the key idea, or so your learning goal for the day, is that you'll be able to factorize an expression by finding the highest common factor. Now, remember that the distributive law can be used to write expressions in factor form. Now, one of the factors needs to be the highest common factor of each term of the expression. Now, the highest common factor is going to go on the outside of the brackets. We'll look at that soon. So to factorize an expression, you write the highest common factor of each term at the front of a pair of brackets with the other factors of each term on the inside of the brackets. So if we have a look here, we've got this factor form and expanded form. So remember yesterday we said this is going to be like 3 times x, which is that bit there. Then there's that plus, we put that plus 3 times 4. And we could simplify that by just saying 3 4s are 12. Now we're going to work backwards today, and I'm going to try and find the common factors of two terms. So if I look at this, what number goes into both 3x and 12? So in my mind, I'm thinking the highest common factor of 3x, well, I've got to say 3 times x, and I've got to say that's like saying 3 times 4. So I just highlight that, and that's what's going to go outside the brackets. And then the inside of the brackets is going to be the other bit. That's that, x, and that plus 4, and that's that bit there. But we'll work up to that. So let's look at a few examples. We've got to factorise 6a plus 18. So what number goes into both 6 and 18? Well, it's got to be 6. So 6 goes on the outside of the brackets. Now 6 times a is 6a, and 6 times 3 is 18. Let's have a look at this one. What number goes into both 20k and 8? Well, 4 5s are 20 and 4 2s are 8. So 4 times 5k is going to be 20k. Carry that minus down, and 4 times 2 is going to be 8. Now you can check if you want. So, and the way you check is just go, well, 4 times 5k, yeah, that's got to be the same. And 4 times negative 2, that's got to be negative 8. And so that's the same. Okay, let's have a look at this one. What goes into both x squared and 7x? Well, x squared is x times x. So that's got to be an x. And that's got to be a plus, carry that down, and that's got to be a 7. Now let's find the highest common factor in a pair of terms. So I'm thinking both letters and numbers now, or pronumerals I suppose I should call them. So what number goes into both 6 and 15? Well, 6 is 2 times 3 and 15 is 5 times 3. So I've got to have, first of all, the coefficient 3. And then I can see that b is both common to both of these terms. Now, that's good. So the coefficient of both, we're just finding the highest common factor of both of those in this example. So that's just 3b. If I were to factorise 6ab plus 15b, I would just be saying, well, the highest common factor is 3b, and what's uncommon goes inside the brackets. So 3 times 2 is 6, and then that'll be an a. 5 times 3 is 15, so that'll be a 5. And that's that factorised. But that's not even, it's only asking you here, what's the common factor, highest common factor of that, which is 3b. Now we're going to factorise each expression. So, this case, well, look, there's an a common to both of them and a c common to both of them. So, what's going to go on the outside of the brackets is what's common, the a and the b, the a and the c even. A and the c, well, that means b goes on the inside, and this is just got to be 4 here. Now let's have a look at the next one. 15 and 25. Well, they're both multiples of 5. Now we've got a km and an mn, so the letter common is m. Now 5 times 3 is 15, and the other letter is k. We carry the minus through. 5 5s are 25, so there we go. And then the other letter is n. Now 4 goes into both 8 and 12. Now, oh, this is interesting. 4y goes into 8y and also goes into 12y squared. So remember, if I'm looking at this one, this is 4 times 3, and this is times y times y. So that's going to be 2 there. We're going to carry that minus through. Now the 4 and the y is being over on the left hand side of the bracket, so what's left here is 3y. So that's that factorised. Now this is an interesting one. What can you see here is that the second term in each bracket is the same. So what's nice about this, and I'll just show you this simply, is that that's going to be our second set of brackets. So our first set of brackets is what's left over. In this case, that's a plus 7 and that's a plus y. So this is just going to be y plus 7 multiplied by x plus 3. So that's a nice pattern. Likewise over here, we've got that what's inside the brackets is the same. So let's write this. 4k, take 5, and the other two brackets are the same, so that's going to be the same there. Now we want to factorise by grouping terms. So this is a little bit trickier now. So what do we need to do? We need to just say, well, this is going to be one group here, this is going to be another group here, and then we can do it. So what's common to both of these, the first brackets? Well, let's have a look. We've got an x that goes on the outside, and then that's got to be a y plus 2. Now, what's common to both of these? Well, there's a 3, and it's a plus 3. Now, that's got to be a y, and 6 divided by 3 is 2. Oh, so this is quite nice, isn't it? So you can see that y plus 2 is common to both of these brackets. So then we can just say, well, x plus 3, and then y plus 2 is going to be the second term. So that's nicely done. I'll just pop into this area model of factorisation, so when we're expanding brackets before, and I might go to the one with some variables just to head here. Let's say we've got 2x, and we'll say plus 5, and we've got 3x plus 2. We've got 4 different terms. Oh, I said a minus there. Oh, well, I can live with that. Let's see what we're saying. Well, we're saying 2 times 3 is 6. X times x is x squared. What have we got over here? Negative 5 times 3x. Well, that's negative 15x. Here we've got 2x times 2. Well, that's 4x. And we've got negative 5 times 2. Well, it's got to be negative 10. We can also calculate the area there, so that's the calculations. So if we're using the distributive law, what are we doing? We are going to go through a few different steps. We're just going to say, well, 6x squared plus, oh no, that's a take of 15x, plus a 4x, take 10. Now we've got, well, we don't even want to worry about this step at the moment. We're just worrying about this step. We want to see that we've got an x and an x and a 3x and a 3x, which is common to that part. So you can see that that 3x, which is common there, is over here. And let's have a look here. We've got a 4x and a take 10. So we've got a positive 2, which is common over here. And that's it over there. And I think that'll do us for the moment. I'll get you to jump into your mastery exercises after you've taken the right notes and have a go at them.